Good morning, friends. This is just going to be a talk about a new slide deck that I'm encouraging you if you're working with School of Tomorrow, if you're pushing out this knowledge we have, you're invited, say, to a symposium. And I'm going to change the name right here, the subtitle here, because it's too cryptic as it is, Symposium. Because it was recommended to me that that's kind of what this is about in a sense of time frame. It's not just like one quick lecture. I'm not going to do a long talk. I'm just giving you the structure, and it's like grad school computer science level, let's say, because there's some Python programming, there's algorithms a little bit, there's some vector math, and we kind of assume some background, but we also giving it as an introductory talk about synergetics. But I'm casting this as a work in the humanities where we study some math that's considered offbeat, esoteric, and, multidisciplinary. It's mostly prose, it's philosophical. If you've studied synergetics, and that's kind of where I'd expect you'd have come from to give this talk. In other words, I'm going to give you advice as a presenter how you can do this talk in a symposium setting as an invited speaker. And I would use the first person. If I were the one doing these slides, then there are places where I would talk about myself. But you don't have to be me to do these slides. This slide, so I'm telling people some of the background on synergetics. So what I want to establish in the very beginning of the slides is what it looks like, and I deliberately pick one of these most it's clearly, if you read this with words like eternal and love and verities, it's also the dictionary label special cases. He's aware of his own vocabulary being remote. There's a whole section on the remoteness of the synergetics vocabulary. It's tempting to throw it in right here. Instead, I have whole other YouTubes about that. But this is not a math book, clearly. I wouldn't call it a physics book, clearly. What does this look like? Where it talks about, these kind of words that it's throwing around look to me like philosophy, right? And yet there's a lot of math in it. He uses the 4D early on. Here's from 1928 to characterize his thinking, and I talk about the shakeout all through the 1900s around this 4D meme. Like, what is the fourth dimension? It's not like there's one right answer to that question. And by shakeout, I mean at the beginning of the 1900s, as this book here documents, the fourth dimension and non-Euclidean geometry in modern art. It chronicles the 1900s and shows how it's working in the art world and so on. Fuller's working in Shelter Magazine. He's in the architecture world, patent world. So he's not really considered an artist, so to speak, but he figures in this book. Remember Ouspensky wrote a book called Fourth Dimensional Man or something like that, right? It was big, but then it kind of distills down. I'll jump ahead to this slide to 3 namespaces. I'm going to say 3 shop talks, and distinguishing the first 2, the Coxeter polytopes way of talking about fourth dimension and the Einstein way. Just to be brief about it, you could say the one is Hilbert space. Coxeter is working in a Hilbert space, kind of linear algebra vector space, what we're used to. Higher dimensions, no problem. As high as you want to go. Hypercubes, 10-dimensional, no problem. That's where Coxeter's operating, and that's called Hilbert space, you could call it. And then Minkowski space. What's going on in this quote, by the way? Minkowski space is what Einstein's doing, and Coxeter is saying they're not the same. And in this paragraph, and that science fiction writers come along. He mentions J.W. Dunn, or is that Dune? And, they take their liberties. They mix together these 2 meanings of 4D, but it's not really strictly, useful to do that, except in science fiction, to kind of as a plot device to mix the Einstein sense of 4D with the Hilbert space and Minkowski space are not the same, basically. And so we already have that distinction of two different meanings for 4D, and I'm saying there's a third meaning for 4D that really survives the 1900s because we're still talking about it today in this slideshow, but it's different from the first two. But as you can see, it goes back. There's Fuller taking up that meme or logo, like a brand, you could say, as far back as 1928, when he starts on his concerted focus on this. Like it had been in the back of his mind, but he'd been at Harvard, he'd been in the Navy, and now he was trying to be a civilian, and that wasn't working out so well. It was getting rougher and rougher, and then he decided abruptly to switch gears, go back to those kind of ruminations, figure out a way to become somebody in his own right, basically, because he was kind of being buffeted by the Al Capones on the one hand and the J.P. Morgan bankers on the other, like two subcultures. It's going to be really hard to just be little Bucky. He's going to have to reinvent himself, and that he does, around his intuitions having to do with, he wasn't sure spheres basically, but he wasn't calling it synergetics yet. So there's Bucky and Applewhite. It's a famous picture. You'll find it on the dust jacket of Cosmic Fishing by Applewhite. But the point here, okay, I want to give overall structure, not really the whole talk. The interesting feature here is this slide is found elsewhere. And if you click on linked slide, the little three dots, then you can open in the source and jump to a whole other deck. In this case, I think we'll jump to cultigory theory, not graph theory. And so you're at the mouth of many rabbit holes, in other words. These are like hyper slides. Let me go into slideshow mode and do the rest of these, I'm going to say, in 5 minutes, giving myself a deadline. Kind of lightning talk, because I don't want to do the whole show here. I just want to give you, a would-be presenter or someone who's currently presenting this, I'm giving you tips as someone on the sidelines saying, here's the whole structure. So start from the beginning to review real quickly. What is Synergetics? That's what it looks like. It got started in 1928. We already have in the 1900s a bifurcation into two main, I'd say, domains or shop talks where 4D is used. One is typified by Coxeter, and that's HSM Coxeter, and the other is typified by all the relativity, special relativity, general relativity, mathematics there, where it's 3D plus time. That's what you learn, right? That the fourth dimension is time. Makes perfect sense, world lines, all that, time tunnels. It's a good thing. I'm not saying any of these are wrong. I'm just saying they're like different sort of shop talks. And by the way, we know that Fuller, there with the American Express card in his hand, is dedicating Synergetics, the book, to Coxeter there in the middle. And there's a relationship between the two, which you can read about, like in Siobhan Roberts' book, The King of Infinite Space, is a bio of Coxeter, and Fuller appears in that. You could read about that. Then I scrounged up this paragraph a long time ago in library reading. Carl Menger, turns out I knew his daughter, didn't know that at first, that they were related, but she was one of the Wanderers. Now, I get into the Wanderers when I give these slides, probably more than anyone else who would deliver these slides and talk about me in the third person, which is what I'm encouraging. Like, just throw my story in there, have me be another character. But when I do it, it's going to be more detailed, of course, in ways that, I can go down my rabbit hole deeper than most people, right? Okay, so Carl Menger, I dig him up in the Multnomah County Library or somewhere and say, wow, this sounds a lot like Synergetics. But this is from 1949, and he's saying, why don't we think of axiomatizing differently, where we still have points, lines, planes, and volumes, like polyhedra, but they don't have to differ in how many dimensions they have. They really are just, it's topologically different, a plane from a point, but not in terms of how many dimensions they have. And that kind of sets a stage for Fuller's use of 4D, which is like it's 4D all the way down, but then you can add frequency, which is like Einstein's time more. Time, energy, all that kind of gets handled in frequency, where you can have data structures of any dimension. Like we have Hilbert space embedded in frequency, I guess you could say. I won't talk about it quite like that usually. But there we've got the sort of opening slide of another slide deck, not the opening slide, but a key slide thereof. And the first thing, okay, I'm giving myself 5 minutes, is I want to talk about the skeleton. In other words, this is bones and bodies, and these are the bones, the vectors. And also, though, I want to plant the seeds right at the same time for the volumes, the whole number volumes, so to speak, the octahedron, tetrahedron, and so on. So the difference in how we do third powering and the way that 4D is used in the language of synergetics, and how this is prefigured in this letter that came through the Huffington Post. Someone unearthed it, a journalist by the name of Susan Mazur. I don't know this person, but this did come up in the 2017 Huffington Post, and it's a letter from Darcy Thompson to Alfred North Whitehead, and he's exactly asking, why do we say space is three-dimensional? If we had tetrahedral coordinates, wouldn't we say it's a four-dimensional space? Like he doesn't want to say, and Fuller either, that our civilization is committed to saying space is 3D. There could be, I mean, that could be a huge school of thought, but it's more of an ethnosphere than sort of, it's not self-evidently the only way we can think. And here's an alternative. And the quadrats are going to come in useful as an alternative vector structure. And that's what I mean by the skeleton or the bones. So you get into sphere packing deeply, talk about that, and then here's where I'd introduce myself. So we're into the symposium. It's going to take place over maybe 3 to 4 days. We're going to have a series of talks based on this one deck with all of its side steps, all of its possible links to, this would go to Graph Theory 2025. The point being, to make my story short, I study under Rorty on the left, Kaufman on the right, and I pick up different things from both. I get into Wittgenstein, and like from Kaufman, who's the Nietzsche translator, I learn about S. Now there's a longer story about this I could talk about. And I'm tracking Erhard, therefore, on the right, or on the far left, on my your viewer's far left, who's walking arm in arm with Buckminster Fuller. And that's kind of when I switched my attention, or you could say this railroaded me from training to following Erhard to also following Bucky. Erhard at this time is like 90 years old. I haven't met him in person, but I've met all kinds of the organization I got steeped in. So at Princeton, I pick up on Wittgenstein, write a thesis on him. By the time I've gotten through Est, have been tracking Werner Erhard and tracking his interests in Bucky, Buckminster Fuller on the right here, I'm in Jersey City. I've moved from Princeton north to this city right across from Manhattan in the shadow of the Statue of Liberty. I've continued with some of the same housemates from 2 Dickinson Street in in Princeton. Now I'm in Portland. And so at this stage of my life, like 1980s early, I eventually work in a Catholic girls' school in Jersey City, and I'm kind of like in that kind of like when the caterpillar has made the sac, the cocoon, and has dissolved. It's like I was dissolving in Jersey City, having done all this study and bringing in of all this thinking of Fuller's and Est and everything. It's time to turn into whoever I was going to be the next chapter. flash forward, and I've spent a lot of time with the Bucky stuff and met all kinds of people through that. Jay Baldwin, Kyoshi Kirimiya, and so on. At Applewhite, D.W. Jacobs there. Peter Meisen, good friend of D.W. Jacobs, and Trevor Blake, good friend of mine. I have a career teaching Python, and this comes after working in Visual Fox Pro. I mean, I've had a long career as computer applications developer, and then teaching Python and so on. And then the Wanderers comes to us through the Linus Pauling lineage. Linus being a Nobel Prize winner in chemistry, also peace, and this was his boyhood home. And I tell a lot of stories about that, but we would meet there weekly in connection with a lecture series, the Linus Pauling Memorial Lecture Series, which has all kinds of big name thinkers coming through Portland, thanks to Terry Bristol, the president of the nonprofit behind it, for which my wife was a bookkeeper and I was like a volunteer technician, but helping him with the mail list, comes in all different formats, do computer stuff. And we got, therefore, free tickets or compensated with tickets to all these lectures and dinners after. It's very good synergy for us. So then we get into the quadrays. We talk about the software, the interactivity of it, where we could treat them as a language game, kind of in a Wittgensteinian philosophy of math sense, history of their development. And then here in the Wikipedia page, I would say there in the volume column, we start the other theme. Like this is the bones, the vectors, but we're going to get to the volumes. So you learn enough Python, you learn enough about the geometry. Like there's homework behind being able to present these slides. But a lot of you have already done that homework. So it's just a matter of icing on the cake here. The connection to Sam Lanahan in connection with this soccer balls looking structure in front of my house. These are C60 balls held together by struts. It's very clever, very robust framework that Sam developed in several prototypes, C60 being one of them. That's C6XTY. C6XTY is how he spells it, the number 6. It's part of the branding, okay? And his grandparents are the Fitzgeralds up there. That's my yearbook picture. So I'm trying to tell my story briefly as coming through Princeton. I'm coming from the Philippines, actually, at high school and studying at Princeton. And Rorty kind of turns me on to Wittgenstein, or I study Wittgenstein under Rorty. From Kaufman, we get the whole other perspective. And we could say through him, I go to Est, and from Est, I'm tracking Earhart, and therefore I add Bucky. As a philosopher, I'm also into, like Wittgenstein. And then I read the Bucky stuff and study and meet his network and become friends with a lot of the same people that he knew. And then I'm also at the same time, after having been a math teacher and other topics, other subjects in Jersey City, I eventually have a career in computer programming and teaching. And then I use that experience to help the quadrays along, which I don't invent so much as they come to me on a listserv devoted to Synergetics, and I continue to work on them as kind of an alternative framework vectorially. And in this animated GIF, I'm gone over 5 minutes, we see vector addition in that if you take the quadrays and stretch one of them to double length, and then add any two of the others, and then don't need the fourth. There's 12 ways to do that permutation. 2 of one and 1 of 2 others. And you get the adding them tip to tail, typical vector addition. You get the 12 surrounding points of the cube octahedron, and this becomes important in this Python algorithm. Here you see all the code for developing using quadrays now. Using quadrays, we create this um, kind of graphics, these kinds of graphics, higher and higher frequency cube octahedron, which makes a cool way to teach crystallography. Now this slide I would take all the way back and connect to, or let's see, all the way forward. There's a slide here I'd like to add maybe, if I don't have it yet. Okay, let me see. How do I add a slide that I don't see? Do I really not see it here? There you get a sense of everything that's there. This ends talking about unification of steam and path. In other words, on the A, I say A for anthropology, this little crisscross of the two, path and steam. So I end, and I would suggest the symposium could end with these kind of questions. Does synergetics bridge the gap between, say, this kind of click and STEM, this being a literary kind of path click, Hugh Kenner and so forth? I play up Ezra Pound quite a bit in this. And I do talk about his controversial, he's got a lot of geopolitical controversy. He's kind of a fascist, and he feels all washed up at the end in Italy. And then Fuller comes and gives a talk, which he attends, and he is cheered up, and he puts a famous inscription in one of those books. I feel like I should probably add that as a slide and tell that whole story of Ezra Pound at the end. We get to the Koski identities. We talk about the S modules, the beast modules, the T and the E modules. All of this is from other slides, other decks. So when you get to the point where you're ready to do the symposium, you already know about the synergetics constant, ways to compute volume, and this very important slide about, alternative ways to visualize 5 times 2 times 2 or any A times B times C along the lines of how we model the multiplication or third powering in synergetics, right? It's like on the left, we can, using a 60-60 degree angle, go out 2, 2, and 5, close the lid, and this skew-shaped tetrahedron is our volume 20. It's not a prism. We're not thinking in terms of right angles, although we're free to switch back and forth and do. It's not like we're giving up XYZ. We're not turning our back on all of that. If we need it as a toolbox, there it is. Anything that works is fair game to keep using, and so we do. We have interactivity between IVM and XYZ embedded right in the definition of quadrate coordinates. So the slide I want to make sure we have is actually here already. It's very easy let's do a copy. It's okay to have the same slide appear in more than one place. And when we get down to, say, this slide, or after we do these multiple frequency slides, I think right here I will insert, and we'll look at this slide again, talk about it a second time. So paste. Oh, they want me to install that. I don't want to install that. Control V, it's already installed. Okay, so there it is. And it's still a linked slide. You can still go back to, if I say open source, you're suddenly in a whole nother slide deck, dimension in Synergetics. So you see how this can be a whole symposium, because now we're in a whole nother slide deck with more details about everything, and so on. So we're in a hyper slides. It's kind of a maze, and it's certainly enough for 2 or 3 days, as my reviewers said. Where this slide deck comes from is a process I went through with Mount Hood Community College where they were interested in my material, but trying to see if it was a good fit for what they do through what they call the Dead Mathematician Society. And it was not a good fit because they're looking for talks that reinforce topics already embedded in the curriculum, like compound interest is the next one, the next talk. My stuff, on the other hand, this material, as you know, 2025, is offbeat, it's out there, it's esoteric, and it's entertaining, and there's a lot here, and that's why we do a symposium. But it wasn't like a quick 45-minute talk about some existing curriculum elements already embedded in the curriculum. It was a rabbit hole off into a whole nother world, a portal. And they didn't need a portal. Even if it's Dead Mathematician Society, we don't have to get too out there here, was the verdict, and I understood that. It made perfect sense. So I kept the deck, though, because I made the deck to say, hey, here's what I'm into. And I mixed it up from previous decks, and I linked slides. And so even though we decided not to go ahead in that venue, they said, but, look, this is high level, this is grad school level, this is like computer science stuff mixed with other stuff. Go to PSU, give a symposium or something there, or whatever. Just like do a big thing, kind of PhD level kind of stuff. So that was like flattering. It's like, wow, yeah, I could do that. So you could do that too. Any of us could if we've got the homework. And I'm saying, don't let the pictures of me, just because you're not me, it's like, oh, I shouldn't talk about this. I shouldn't use this deck. That's the whole point, is I'm trying to get away from only one person can use this deck, i.e. me. No, I want this to be available so that the work that's gone into this, you don't have to reinvent the wheel every time, right? There's already enough here that you could start this symposium tomorrow and use these slides. So think about it. Ask me questions if you have any. Go read or look previous YouTubes in my channel, like the homework that you might need to do, like what's this about, and this other few slides, what's the S module, stuff like that. And do you know any Python? Do you want to present it? If you're not, I'd say you could get away with that. You could say there is Python around here, but you're not the one who's going to talk about it. Somebody else is. And maybe the symposium, there's, several speakers and several workshops and all this kind of thing. So it can play into many different scenarios, these slides, and that's why I'm presenting them. And I hope this looks interesting to you, and may the ship sail forward. Sounds like a good one. Talk to you later.